Hello, everyone, and welcome to the webinar, Your Easy Button for Scaling Azure IoT at the Edge. My name is Sarah Bodine, and I'm happy to be your moderator today. Before we get started, I wanted to cover a couple of housekeeping items. First off, you'll see a Q&A option at the bottom of your Zoom screen. Please use this to submit any questions you might have. We'll be sure to save time at the end of the presentation to answer those. If we run out of the time and aren't able to get to all the questions, we'll follow up via email. The webinar will be recorded and available on demand. We'll send that out later this week. And then finally, one of you will be lucky enough to win a Microsoft Surface Go 2 today. We'll announce a winner at the end of the webinar, so please be sure to stick around at the end. You must be present to win. And now I'd like to introduce our speakers. Luciano Torres is the technical product owner of IoT at BOBST, where he develops the platform foundation for the digital solutions that BOBST offers for its customers, including the device management, configuration and monitoring, and global architecture. Luciano has led the development of innovative solutions in the industry in the past 20 plus years at BOBST, Siemens, and ICPA, among others. Steve Busby is a principal program manager with Microsoft on the Azure IoT engineering team, specializing in helping partners and customers realize the business value of IoT and digital twins. Steve is a longtime Microsoft veteran, having spent time in Microsoft's consulting group before moving on to run the Microsoft Technology Center in Atlanta. The MTC is a high-end proof of concept testing facility that allows Microsoft's enterprise customers to prove out the functionality, performance, and scalability of Microsoft solutions before purchase and implementation. Prior to Microsoft, Steve was an application developer in the systems planning division of Southern Company Services. He is a BS in electrical engineering from the University of Alabama at Birmingham. And Jason Shepard. Jason is the VP of Ecosystem at ZEDEDA. Prior to joining ZEDEDA, Jason was CTO for the Dell Technologies Edge and IoT Solutions division. His proven track record as a thought leader in the market is evidenced through his leadership building up the award-winning Dell IoT Solutions Partner Program and establishing the vendor-neutral open-source EdgeX Foundry project to facilitate greater interoperability at the IoT Edge. Jason is active in the Linux Foundation's Edge Umbrella project and other key industry efforts focused on IoT and edge computing. And with that, I'll hand things over to Jason to kick things off.
So we're gonna do a quick intro to ZEDEDA, talk a little bit about Edge, because there's a lot of confusion about Edge these days. Steve will provide an overview of Azure IoT, and then Luciano will walk through BOBST's overall journey working with ZEDEDA, Azure IoT, what they're doing with their business when it comes to IoT and Edge. And then we'll have a panel discussion, just kind of talk a little bit more about some of the details and kind of what we see is coming up next. Definitely, again, feel free to ask questions as we go. So a lot of Edge conversation, major trend. It's not like the cloud's going away by any means. We're just going to see more and more processing happening everywhere. Gartner estimates that 75% of data will be analyzed at the edge or processed at the edge the next few years. By 2025, like 30% of the workloads will be deployed at the edge. So, again, really important to think of it as an augmentation to cloud, and edge and cloud working together, but definitely more distribution throughout networks as we move forward because of the sheer amount of data that's coming online. So this is a quick kind of evolution that we've seen in the space over the past number of years. So IoT was a major trend, starting in 2015. Obviously, these types of connected systems have been around for a long time, but IoT as a trend represents embedded systems hitting scale. This drives more data in addition to the data that we've already had. This is creating an overload on networks, hence the reason for edge computing today. Latency is certainly one of the driving factors for edge computing, but actually bandwidth is something that we see very consistently as a major driver because it costs money to unnecessarily move data around. So clearly there's a trend for more and more compute. Also, cloud native principles, platform independence, loosely coupled microservices, continuous delivery of software everywhere, and so edge is an evolution of cloud in that standpoint as well. Where we see this headed is this notion of increasingly interconnected ecosystems, whether it's retail, manufacturing within a city, in the home, the energy space. And to get there, you have to have an open foundation. This is part of the reason why ZEDEDA, we've rooted our foundation in open source. If you don't have transparency in how data is shared, this notion of trust fabrics is a conversation we're spinning up in the industry with a number of providers. How do I deliver data with measurable confidence across networks? Well, it starts with an open foundation. More and more compute everywhere, new business models, new experiences driven by these interconnected ecosystems. And so, we're all about how do we help customers today, but also how do we bridge to the future potential in the long run. So edge is a continuum. A lot of people saying near edge, far edge, thin edge, thick edge, and it gets confusing because they're terms that are relative depending on your perspective. It's a good read. I would recommend checking out the LF Edge taxonomy white paper. You can find it easily online if you haven't seen that before. And that paper goes through how edge is a continuum, starting with constrained devices out in the field, highly constrained in terms of resources, to centralized data centers, in the cloud. And there's inherent trade-offs that from a technical standpoint, and to some degree logistics. If you're a latency critical workload, like deploying your airbag, you will not run that over a wide area network. So that's one trade-off, is the user or device that you're serving on a wide area, local area network. Number two, is it in a secure data center or not? When it's not in a secure data center, of course, there's unique considerations around security. Number three is the resource so constrained that it can't support an abstraction layer, like for virtualization or containerization. All of these dictate different types of tool sets, so that there's a lot of data center tool sets that are applicable on the right side. On the left side, it's very, very constrained to the point where everything's custom for the device. And this distributed edge, which is where ZEDEDA is focused, this is that distinction between a single compute node that's capable of running abstraction for workloads up to the fringes of the data center. So that's going to be the focus of the conversation today. In terms of the use cases that we're talking about, the work that BOBST is doing, that Luciano is leading, and more. So very important context setting that edge is not one thing. So we'll talk about the distributed edge. These types of deployments are inherently complex. The further left you go towards the physical world from the centralized cloud, everything gets more complex. Skill sets are more diverse, lots of different types of hardware and software. You have many legacy investments within the field. How do you remotely manage that? How do you deal with security threats when you're not in the physically secure data center? You might not have a network perimeter. You've got a mix of expertise between OT and IT, so the operations group and the IT group, and different folks, even within that do different things. And so you have to accommodate all of these challenges and then do it at scale, because again, the further left you go, things not only get more complex, but also more volume in terms of deployment scale. So the focus at ZEDEDA, 100% on edge orchestration. We're not in the data path. We are all about how do you scale securely deployments that while meeting all of those challenges that we just ran through. How do you support legacy applications alongside modern apps, whether they're containerized or they're Kubernetes clusters? I have a Windows-based application running on my factory floor. I can't just change that and scrap that today. I need to be able to use that while I invest in new software. I need to be able to accommodate deployment without having specific skill sets all over the place, especially out in the field where technicians would roll a truck and deploy something. Definitely need to consider security. We'll talk about that at length as we go. I need to be able to scale. In the cloud sense, there's tens of public clouds that matter long term, or centralized clouds. In the device edge, there's trillion, and the distributed edge, we're talking about somewhere in between, but it is an exponential scale factor. I have to maximize uptime. Safety is a consideration when you're out in the physical world, and I need to be able to do all the above while maintaining flexibility for the long term. So these are all the factors that we've considered from the ZEDEDA standpoint as we've built out our offer. There's two key components to the ZEDEDA offer. One is our cloud orchestration console. This is a SaaS-based solution, pay as you grow subscription. This provides that UI where you get full manageability and observability across all of the nodes distributed out in the field. You can deploy apps. We have a public marketplace that can also be built into a private marketplace with the apps that you care about for your business, or if you're a system integrator or an OEM, you can create your own. It's all about simplifying orchestration of hardware and applications out in the field. We leverage EVE-OS, which is hosted within the Linux Foundation's LF Edge project. By hosting EVE-OS within LF Edge, it makes it completely vendor neutral. And think of EVE-OS as like the Android of the edge. So just like Android is not just Linux, it's got JVMs in it, it's got all this extra curated technology within it. Eve is not just Linux. In fact, that it's got embedded hypervisor, it has all these features around security, and it's very, very curated to address all of those challenges at the edge that we just talked about. And just like Android, the goal with EVE-OS is to build an ecosystem that's open of hardware and software that enables you to scale. And so then as a business or a developer, you can focus on value versus reinventing those foundational ingredients. And this is also why it really matters to be vendor neutral as part of Linux Foundation. So EVE-OS is the open component that runs at the edge, and then we have our cloud component on top. So if you look at the two components in context, think of this as a piece of edge hardware running. Could be any type of silicon, ARM, x86, co-processors like GPUs, FPGAs. This can be a gateway, a hub, a router, a server. It's just distributed out in the field, this hardware. EVE-OS would run on top of that as a bare metal foundation and create a universal abstraction. So any application that comes on top sees Eve, but it doesn't have to be concerned about the hardware below. Eve within it has this embedded hypervisor, which will support virtual machines, as well as it will support containers, and we can also support Kubernetes clusters with this foundation. It taps deep into root of trust within the hardware. It does measured boot, secure boot, full disk encryption, encryption of data in motion, creates a crypto-based ID, so you don't even have a username and password anymore, because that's one of the threat vectors, is where people can log on locally and do stuff to the box. All these extra features from a zero trust security standpoint that you don't get when you come from a tops down container first model. And so we started the lowest point where you just can't, you have to go embedded below it on that continuum. Create that universal abstraction layer, make it completely open, with that Android model, and then you build an ecosystem on top that enables developers and end users to do more. You take your pick of where the data goes. ZEDEDA is not in the data path at all, whether it goes on-prem or into the cloud. And then we provide that cloud console. It leverages the open APIs from EVE-OS, but you're not locked in even to ZEDEDA. We think it's really important in this market. You win by merit, not lock-in. This gives customers choice. They love the fact that they can just buy the console and go and focus on applications and different points of value. But it is a really nice benefit that it's part of an open ecosystem. You drop a box on a network, connect power, and at that point you can leave. You can do everything remotely from the cloud, including single click of any choice of applications, full visibility at scale. And a lot of extra features. We'll send with the package out some white papers and both on architecture and security, and some other pieces of collateral for more details. Yeah, it's all about the visibility across networks. What's the state of the hardware? What applications are running across a widely distributed area? I can visualize network flows and set policies saying this app can only talk to that cloud, and this app can only talk to that app. So complete visibility and control across your landscape of edge computing hardware. And so with that, I'm gonna hand it off to Steve, who'll do an intro on Azure IoT.
All right. Yeah, thanks, Jason. You can go ahead and move to the next slide if you want to. We wanted to give you guys kind of a sense. You'll hear us talking about Azure IoT Edge and Azure IoT in general. I wanted to give everyone kind of a sense of what does that mean from a platform perspective. We're really focusing on a corner really of Azure IoT platform when we talk about Azure IoT Edge. So I wanted to show the whole picture. I could probably, and I often do, spend 4 hours with a customer talking about this one slide, but I really just wanted to give a sense of the kind of the breadth of the Azure IoT platform. We've got components that really help you get your things connected, get your devices provisioned, get data flowing to the cloud, into our gateway there in the cloud, a way through our digital twins to really add context to that data, take data from a physical thing into a business context, more than just a group of sensors, but what do they mean in the context of higher level abstracts like floors and rooms and buildings and campuses and things like that. We have analytics tools for analyzing the data based on pretty much any volume or velocity you're looking for, whether that's hot path, near real-time analytics, whether that's warm path, kind of looking at the data as it has existed in the past, days or weeks or months, and then cold path for long-term storage of massive amounts of data for compliance reasons or training of machine learning models and things like that. So we've got a breadth of platform there for really working with ingesting and then doing something useful with your IoT data. In this particular case, Jason, if you want to go ahead and click once, we're going to really be talking about two of the services and mostly one, and that's Azure IoT Hub and Azure IoT Edge. So if anyone's not familiar with it, Azure IoT Hub basically is the connection point for devices in the cloud. It's a bidirectional endpoint in the cloud for ingesting telemetry. So it's both kind of a data plane for ingesting data into the cloud at high scale, high speed, high performance, and being able to ingest all kinds of different data and IoT data into the cloud. But more importantly, it's also can be a control plane for devices in the field. So the idea there is, not only can I pull data off these devices, but I can reach out and affect the configuration of the device and affect the, even invoke functionality remotely on these devices. And we're going to talk a little bit about that when we talk about IoT Edge. So one of the reasons you need to know that is this is how we do partial management of the Azure IoT Edge box. And we'll talk about kind of where our boundaries end in terms of what we can manage on that IoT Edge box. So Jason, go ahead, the next one. So I do want to talk a little bit about the evolution that we've had here. For us and for a lot of the real hyperscale IoT vendors, IoT started in the cloud. We've had people say, we've been doing IoT for a couple of decades now with things like SCADA systems and things like that. But IoT really took off in that 2015 timeframe that Jason was talking about, when we got to the point where we could do something useful with large amounts of data. Customers were doing IoT, but they were throwing a significant amount of that data away because they couldn't afford to store it. They couldn't afford to crunch through that data or do anything useful with it. So go ahead and click, Jason. Actually, you can go ahead and build this one out if you want to. IoT really took off when we had the infinite compute resources of the cloud, the ability to get all that data into the cloud and do something useful with it, train machine learning models, store it indefinitely in a cost-effective manner, crunch through it in a big data Hadoop type fashion, and it was good. But the problem, as Jason pointed out earlier, is that sending all that data to the cloud can be costly, requires a permanent, a consistent internet connection, and we all know, if you look at things like manufacturing plants, those aren't typically built where connectivity is good. They're built where land and labor are both cost effective. So we saw a kind of a pendulum swing back towards some of this local processing as well, processing data on the edge. So the ability to have continue to operate if I was offline, or filter and aggregate data at the edge before or possibly even instead of that data going to the cloud. These low latency control loops. If I recognize something's wrong via some predictive algorithm and some machine's going to blow apart pretty quickly if I don't take action, then I can you can do that processing on the edge even if the device is offline. So Microsoft's goal as we built out Azure IoT Edge was to really bring some consistency to these two models. So what we didn't want to have happen was you have one development paradigm for the cloud and another development paradigm for the edge. So what you'll see here in a later slide is we've taken the ability to have a lot of those services that you saw on the previous slide. So the warm path analytics, the machine learning, the ability to do some of this crunching of data in the cloud, and take basically those pretty much unchanged, those exact same resources, and run them down on the edge and configure and maintain that remotely. So go ahead, next slide, Jason. So if you look at some of the kind of the top scenarios that people use IoT Edge for, really probably the four you see on the top there are the main ones that we see most often. And that's, getting devices connected. So there's a lot of brownfield kind of devices out there that, many of which were born before the internet. They don't speak internet protocols. They don't know anything about the internet. They can't be connected to the internet because they don't know how to protect themselves in that environment. So we use Edge a lot for what we call protocol translation. So the ability to basically, talk to the device in its native tongue internally, and then talk to the cloud via cloud native protocols. The ability to process and aggregate data at the edge. So if I've got a machine, say an old PLC that sends data out once a second, just kind of blindly, I don't want that data to go to the cloud once a second. I might want to aggregate that once a minute, once every 5 minutes, once every 10 minutes. I might not want to send any data to the cloud unless I detect an anomaly or that data changes. The other use case here is I really want to be able to continue to do all of this stuff offline as well. So I want to take advantage of the cloud, but I want to do that if I lose my internet connectivity and have all of this stuff still continue running, as well as some of the capabilities built into IoT Edge will do things like store and forward. So I can take this data that's coming into IoT Edge, and if I lose my internet connection, I'll just keep that data locally and forward it to the cloud when my internet connection resumes. The other thing the other use case that's really coming on heavily on the edge is analytics and visualization. So I mentioned earlier we can take some of these Azure services and push them down to the edge. Well, that includes things like machine learning algorithms and vision-based use cases. So I have the ability to hook up cameras to an IoT Edge box, for example, and do vision-based AI on the edge, or auditory-based AI. So I can put an audio sensor on a machine and listen to noise to see and try to predict if a bearing is going to fail or something like that. Both the visualization and other machine learning algorithms, they can be developed and trained in the cloud and then pushed down to execute on the edge, where they do so with low latency without sending all of that data to the cloud, and do so offline. So that leads to a lot of the use cases you see below. The remote monitoring is kind of, I consider that table stakes for an IoT solution. It's not an IoT solution if you can't remotely monitor something. But the ability to move into predictive analytics, predictive maintenance, computer vision, manage these things remotely and at scale, and process and store the data locally as you need to, are really as IoT has matured over the last 6 or 7 years. It's those use cases that are starting to come to the forefront as the solutions get more capable on the IoT side. So go ahead, Jason. We're going to spend a little bit of time on this next slide here. So what is IoT Edge and how does it work? I've talked a little bit about the ability to take these cloud services and roll them out remotely, and manage them on the edge. So go ahead and give me one click here. So IoT Edge from Microsoft is for the most part a runtime and a set of services in Azure that can be pushed down to the edge. So you'll notice the very first step in getting IoT Edge up and going on a piece of hardware locally is to provision the right runtime on that device and get that runtime installed. We're going to circle back around to how you do that here in a few minutes. But ultimately, the Edge runtime is where it all starts. That's what bootstraps everything else. It's based on a hardware root of trust on the box that Jason mentioned earlier, the ability to interface with this hardware encryption, and it runs on a base OS. We support Linux and Windows for IoT Edge. We support most flavors of Linux and Windows, modern versions of Windows. So once you get the Edge runtime installed, then it's going to connect to IoT Hub, which I mentioned earlier is the control plane in Azure IoT for IoT devices. So you can kind of at scale configure the IoT Edge device once it's installed and running. So go ahead and click the next one. And the way you do that is with a thing in IoT Hub called the device twin. So the device twin really stores current state and configuration for any IoT device, including IoT edge devices. So that within that device twin, we store what modules, so what pieces or workloads or chunks of functionality do we want to run on this IoT edge box, and how do I want to route the data between them? And when I say an IoT edge module, that's a containerized workload. So the engine is written to support multiple container engines, but right now we pretty much support Docker. So these modules are Docker containers that can be pulled down from a Docker repository and managed on that IoT. They run and are managed on that IoT edge box, and that can include code that you write. So you might write a solution that talks to some proprietary piece of equipment or does some proprietary processing. You can package that up in a Docker container and run that. It can be third-party things. So I've had customers run things like InfluxDB and Node-RED and Redis cache, all those kinds of things on IoT Edge. Anything that can be containerized for the most part can run and be managed on IoT Edge. The bulk of the services that end up running on IoT Edge, though, are a lot of the Azure services that I mentioned earlier. So streaming analytics for doing near real-time data processing. Azure, Microsoft SQL Server, SQL Edge can actually run on IoT Edge for a SQL data store. I mentioned earlier the machine learning capabilities, the ability to really drive these the ML inferencing down to the edge, so train them in the cloud, drive them to the deploy them to the edge and have them execute there. Blob storage. So Azure, we actually have Azure Blob storage on IoT Edge as well, so you can pull in and store files locally and have those tiered up to the cloud as you do it. So the idea there is that once IoT Edge is up and running, then you can deploy these workloads and manage them centrally from the cloud, and deploy them, keep them up and running, and monitor them as well. And then one more click, Jason. And then the last part here is you can also have devices behind IoT Edge. So these might be smart devices that might otherwise talk directly to the cloud that you want to NAT, for lack of a better word, behind IoT Edge for security purposes, or they could be dumber devices that need IoT Edge to do this protocol translation to get that data to the cloud. And we have lots of examples of those in various industries of deploying these modules to do protocol translation of these devices up to the cloud. But the point here really is these workloads are containerized, and they they can be managed centrally once you get the IoT Edge runtime up and going and get that IoT Edge box established. So go ahead and click one more time, Jason. So kind of blowing up that IoT Edge device there for a second. I mentioned we have a great solution, we think, for managing the containers and managing these workloads on IoT Edge once it's up and going. Go ahead and click through, Jason. But what we don't have, or we give you good instructions for how to install IoT Edge and get the runtime up and going on one box. What we don't do is tell you, great practices for, how do I do this across 1,000 boxes? How do I do this across 10,000 IoT Edge boxes out in the field, which can be, an impediment when you're trying to do this at scale. So that's where ZEDEDA comes in. They really can help with that part of the with managing the IoT Edge box in general, along with the other workloads that run on it, that you might want to run on that same box, because a lot of people, they just run Edge as one workload on a box that might already exist somewhere out in the field. And so, we don't give you a lot of guidance ourselves for doing that. That's really where ZEDEDA comes in. So, Jason, I'll let you take it from here.
Great. No. Thanks for that. No, we at ZEDEDA, we of course support any kind of application, any workload, any cloud, but we strategically picked Microsoft because we obviously think that you guys are making great investments in across the board for IoT and Edge, and a lot of, as you said, a lot of people get, there's different types of management. People get confused. It's like, you guys do all kinds of really cool stuff to manage modules within the runtime, deploying analytics, all the stuff that you mentioned, but getting that runtime out to the field is a consistent problem folks have. I liken it to think of a truck that you guys can put a bunch of stuff inside of the truck and rearrange it and do all this stuff, but we drive the truck out to the field and actually maintain the truck itself.
Exactly, which is the critical first step.
Yeah, it's pretty important part, especially when things are out in the deep field. So as we looked at the trajectory of the clouds, we made a strategic decision to integrate with Azure IoT, working with the Azure product team. We announced this, I think, about a month ago, and a lot of it, we had a number of customers, as Luciano will talk about their journey, coming to us that were already using Azure IoT, Azure IoT Edge, but then had that challenge of how do I scale getting that runtime out into the field and managing the hardware below it. So that's what we do. ZEDEDA is doing that hardware, management. We deliver the runtime. Any other applications you'd like to run in parallel, maybe you have some legacy SCADA software, HMI, a historian, something that runs in Windows. You want to bump it over. Any combination of other containers that you want to run on a common edge hardware box. We've integrated with the APIs in Azure IoT on the back end so that you get some more visibility. But then when you're doing the actual data side of things, you're going to work in Azure within the Azure environment. And so any of the module runtime or deployments on the runtime that Steve mentioned, you can do that within the console that When you want to go manage all of the infrastructure distributed out, that's where our console would come in, also in the cloud, and you get that coordination between the two. Steve mentioned uptime, as being important. This need for offline connectivity. One of the considerations that I'll highlight from a ZEDEDA standpoint is, unlike data center tools, which assume that I've got a constant connection to my server that I'm controlling, and I talk to the server to say, hey, this is the software you need to have, or do this, do that as a controller. We assume you're going to lose connection to that device out in the field, and the device always phones home versus the other way around. So it's what's called an eventual consistency model. You set the state for all the hardware. I want to have Azure IoT Edge out here. I want to have this stuff here. I want to get this kind of visibility. And when those boxes out in the field can phone home, they get that state and they update. And there's actually 2 copies of EVOS running at all times on a box, and it will update in a B partition. Only if it's successful and can run successfully in that sandbox will it flip over. Otherwise, it'll keep running the way it was. So, these are the additional types of considerations in addition to that zero trust security model and just the overall flexibility that really, I think, matter. One last thing, then I'll hand it off to Luciano, is because EVOS is open, because it's flexible across hardware, not only are we building up an application ecosystem working with the community, but also the hardware community. So more and more hardware providers are working with EVOS as an option, including moving towards factory OS options. So as an application provider, you don't have to be as concerned about the hardware side, because scaling support for hardware at the distributed edge is very challenging because there's so many choices between form factors and IO and ruggedization needs and certifications and whatnot. And so that abstraction layer really matters as well. So with that, Luciano, I'll hand it off to you, and thanks again for being here, and let you take it away.
All right. Thanks, Steve. Thanks, Jason and Sarah, to organize all this. So I'm here to tell you guys about our journey in implementing our solution using all the tools you've been hearing so far. So if you go to the next slide, I just explain a little bit who we are at BOBST. I'm not sure everybody here knows about us. So we are one of the world's leading suppliers. Leading means we are often number 1 and number 2 in each segment that we operate. And we provide equipment and services to manufacturers of packaging and label. So we provide these big machines that we see in the back of the photo to our customers, and they are manufacturers of packaging and label. They basically print what you call printers and converters. So what they do with our machines, you can see in the next slide. here you have just a sample, yeah. So basically, they use our machines to manufacture those packages. Manufacture means they do the printing. They can do the corrugated carton and fold, and so make the shape of this packages. This is what you call the folders and gluers. So what you see in the back is the corrugated board, where we did those boxes, very used nowadays for e-commerce. In the front, we see some other types of boxes, what you call the folding carton boxes for the pharmaceutical industries, the toothpaste boxes, you can see as well. We have flexible packaging. Here, the example is the apple juice. You found it everywhere in packages of chips, and our machines, they can be used for printing on those packages, metallizing, coating, laminating, everything that you need to do in the food industry. And finally, you have the label industry, where you see in the example of the whiskey and the shampoo. So we have machines to do the printing on those labels. We have different types. We have very modern digital printing machines that basically can do individually customize labels, each unit printed. But you also have traditional flexible printing and graphical printing. Yeah, so if you go to the next slide, we're pretty much everywhere. We're global. We have 5,600 people in 50 countries, and we have 14 production facilities. As of recently, so a very traditional company. So recently we reached 130 years operating. BOBST is a very traditional Swiss company. And since the beginning, to be market leader in 130 years, of course, we've been leading innovation from the outset. So a lot of innovations BOBST brought to the market today are standard in the industry. And now the next step is very obvious and evident. We're going through a process of digital transformation, where we see in the next slide. Our goal is what you call shaping the future of the packaging industry. BOBST is a very unique position, very central in this industry, where we can connect all the players from the brand owner, for the people designing making the design of the packages, up to all the suppliers involved in the chain, up to the final customer. And we're very well positioned to connect all of them. Basically, yeah, have this backbone of data. For that, we are building a solution called BOBST Connect, which will enable BOBST to enter this new digital world, in where we want to automate all this workflow. So if you go to the next slide, what's BOBST Connect? BOBST Connect is the name of a strategy. So we have this 5 axes where we are targeting our development. One is what you call the pre-press, all the preparation of the printing jobs. So idea is to give agility and efficiency to our customers by providing digital services. Then we have the production solutions that will support our customers while the job is running on the machine, giving full transparent access to all the production data. Then with all this data collected, we can provide insights and recommendations in optimization domain. So we can help our customers to improve their performance basically with all the data that you collect. Then maintenance domain, the maintenance solutions will support customers to ensure the highest equipment readiness, including live interaction with our support technicians. So we can go into the machine and know everything that's going on the machine from a distance, and we can help our customers troubleshoot the machine and so on. And finally, market solutions basically support our customers to get the right parts and services exactly when they need them. Right, so this is BOBST Connect. So we were put in charge to develop this solution, very challenging. So what we had to do, basically, we had to find a solution to connect all BOBST machines, all BOBST clients into this central platform. Not only to a central platform, there's a lot of integration as well with ERP and what you call manufacturing execution systems from the customer. So we need to build this open platform connecting all those machines. We had to manage very different setups. BOBST have a huge variety of machine types and machine configurations, maturity of the technology on those machines as well. So we had to manage all of this. And as mentioned quite a few times today, we have this fleet of devices on the field attached to those machines, and we have to manage them, including managing the software running on them, evolving the software, and doing all of that via networks that are very unpredictable and the quality not very good quite often. So we wanted to basically take the opportunity and build a solution by focusing on what are the core expertise of BOBST, which is our equipment, our production process, and the knowledge that we have in the industry and providing services to our customers, to the packaging and label manufacturers. And then everything else that's not part of our core expertise, we saw as an opportunity to leverage providers in cloud services using serverless technology, platform as a service, and software as a services, such as ZEDEDA. So if we go to the next slide, very high level view. I won't go into much detail, but we use all of the boxes that were mentioned by Steve just now. So what we do, we embed dedicated hardware, all the machines produced by BOBST. In electrical cabinet, we have a hardware that belongs to us. It's in the cabinet. We install a layer, the basic layer. We have an Eve installed in a device, and that allows us to control this device from ZEDEDA portal. So we can do everything we want. Once the machine leaves BOBST, we can perform any sort of configuration and evolution on the device using the ZEDEDA control. Very important when you have a very big fleet on the field. And then for all the software that belongs to our use cases, so implementing our vision, BOBST vision, we run those modules in an Azure IoT Edge runtime using containers that allow us to be very agile, and very quickly we could have things that we could demonstrate things working, that we could show BOBST that this was a worth investment since the beginning, since the proof of concept. So all of that allow us to build the solution, at least the first iteration of the solution, BOBST Connect, which will go live in the second half 2021. So as it's not live yet, I could not show a live snapshot, but this is the type of charts that you can produce live from any machine, any BOBST machine connected to the platform anywhere in the world. You can see this live data. And the first use cases that we will release are equipment monitoring, very basic real-time live information on a telemetry of the machine. Performance management, where we can provide indicators of quality, availability of the machine, and the basic industry standard indicators. Tools management is a use case where we allow the customers to manage the usage of their tools. So every different job recipe that they use, they have a different tool set that they need to use, and this tool set they need to be replaced at some time. They have a special providers of this. So we with BOBST Connect, we want to automate the process of managing those tools. And then recipe and job management essentially is providing a full workflow automation for our customers from the initial design that will be printed on the boxes, from the initial PDFs up to the quality control and the final reports. All of this will be managed in job and recipe management. Everything very much possible and enabled by the solutions we have on the left. Right. So if you go to the next slide, so the partnership with ZEDEDA, I mean, it was very fast, I can say. So from the moment we contacted them and explained what we needed, so we were in the process of making a product out of our proof of concepts of our demonstrators, and we needed something to accelerate all the infrastructure that we needed to deploy those devices on the field. And ZEDEDA was key in giving us all the tools to generate the base images of Ubuntu to support IoT Edge and fully integrated with IoT Edge. So only in a couple of weeks we could have something that we could already see working. And then the process to just customize this image to what we needed was really fast. And yes, we predict that saved us about 6 months time in development. So this solution is now fully integrated into our product. We're scaling up real fast. We see from now to the end of the year, we're going to have about 1,000 additional devices connected to the platform per year. And for the moment, we're even considering new use cases of other possibilities that we can use to manage devices on the machine using ZEDEDA. Right. So I guess this is it.
Yeah. No. Well, we'll open it up for questions and a little panel discussion. But Luciano, thank you so much, and we really appreciate the partnership. And yeah, it's been great. I mean, like you said, I guess we met last fall, and within like 5 weeks we had stuff running out in the field. So great example when you guys already had the vision and come to us, and we've got part of that solution, and of course you were already working with the Azure team. So definitely has been a really great partnership across the board. One of the and I know we've got some Q&A coming in. Sarah, for some reason I can't click on that, so maybe we'll start with a couple of questions I had for the guy, and then we can pepper in some of the Q&A as well. I think there was one in chat also that we can touch on. But one of the, and Luciano, you mentioned this, I mean, with BOBST Connect, and then Steve, I know you see this too, and as do we, is with digital transformation. Of course, there's the technology component. Number one, is there a use case? And clearly you guys have a use case from a BOBST perspective. But the second biggest challenge we often see out there is the people part. Different stakeholders, whether it's IT, OT, the line of business, internal stakeholders to your business or your customers. It's challenging, this whole concept of transformation. So Luciano, for you, I had a question. So you've been a big advocate and kind of champion within BOBST, working with your team, working with your customers. For someone in kind of like a similar position in the industry, what kind of recommendations do you have towards helping people with that type of transformation that you guys are doing? Any advice?
So very good point. It's not easy, but I guess we were very lucky in a sense that from the outset we had a very strong support from the leadership. Essentially, Mr. Jean-Pascal BOBST himself. He is a great sponsor of this project from the outset. Also, what helped is that digital connectivity was not that new to BOBST. So BOBST had some sort of connectivity for the machine for the past 10 years, which was good, but also from another perspective, this makes things a bit harder, because there's always the challenge of why you want to bring something new. But really, we needed to show that in 10 years, lots of things changed, and we need a full revamp of what was there in place. And another thing that was really key was from the very beginning of the first pilots, Industry 4.0 and IoT that we did, that in the end gave birth to this whole BOBST Connect initiative, was to show results very quickly, and that was very important, using Azure IoT Edge at the time, with everything that's offered by Azure IoT Edge. There's a lot of very interesting things that you can show just by putting things together, just by putting boxes that are available together and writing very little code even. So you can demonstrate that there's a lot of things that you can do very quickly, and that gives the motivation to say, okay, we need to go in that direction. There's a lot of things that we can do in this new agile environment that can bring real quick value for our customers.
Yeah, it makes great sense. I mean, this notion of rapid innovation, kind of tops down sponsorship. I think it's kind of tops down and bottoms up in terms of grassroots company and empowering people. But yeah, it's interesting. And you mentioned that I started with that whole vision of interconnected ecosystems, and to get there, this notion of openness and being flexible. But you also mentioned that BOBST is being in the packaging industry, kind of a leader in that space. You are in the middle of all these interconnected ecosystems in a way, and how does BOBST Connect kind of grow that? It's the supply chain is a great example of lots of different stakeholders coming together, and you guys can kind of sit right in the middle and help grow that and drive new types of outcomes. So it's cool stuff. It's everything's connected in some way in the end. So great. So I mean, Steve, a similar question for you is, you work a lot with customers, and you kind of probably see similar challenges as people are kind of evolve their businesses. So what's some advice you have for a project started?
Yeah, I think probably some of the complexity I see is, as you mentioned, it often spans IT, OT in the business, because IT and OT have the expertise to connect the devices in many cases, or can understand the complexities of connecting the devices, but they may not know the business tightly enough to really add the right context to the data to be of value to the business. And of course, the business, they know what they want to model in many cases, or in some cases they might not know what they want to model, but they know that that's not it. Whatever's being delivered out of the devices. So I think one of the biggest challenges we see when people start to get past the basic connectivity part of IoT is contextualizing the data. I've got data coming in from all these sensors. Business doesn't care about sensors. They care about when are my machines going to die, so I can dispatch a service technician ahead of time to do it. They care about manufacturers, they care about overall equipment effectiveness, OEE. They don't care about readings off of individual devices. So being able to take that device data and contextualize it in higher level constructs, like you would do with digital twins or something like that, is I think the next step in helping customers get value out of their IoT, because a lot of them, they had trouble getting started with connectivity. Once they got the connectivity figured out, now they're having trouble figuring out, what to do with all this data. The other challenges that we see, that we often see a lot of times, is kind of an awakening, I guess, of, I really want to do machine learning and predictive maintenance on my machine, and just that there seems to be a lack of realization that in order to train machine learning algorithms, you got to have data. You got to have historical data. So you have to build into, you have to build into your ROI, you have to build into your project plan that I'm going to have to get connected. Then there's going to have to be some period of data collection before I can realize the machine learning based value of IoT. And unfortunately, that's kind of a reality unless they happen to have been gathering a lot of data through some other means ahead of time, which some customers have. But the good news is we've seen, getting started in an IoT project, oftentimes involved a lot more back and forth, a lot more discussion, a lot more ROI type discussions, because there was a large upfront investment. And with the advent of the cloud and the ability to stand services up and tear them down and start small and elastically scale as needed, it's removed a little bit of that friction up front. So it's allowed customers to do what we recommend, which is, don't pick 15 use cases to go after all at once. Pick one use case and your most high value, low hanging fruit use case, and go for it first, and then build from there.
Yeah, and I mean it, and I think that you both touched on something I think that's really key. It's focus on consistent underlying infrastructure, and then the value on top. You mentioned predictive maintenance and just the different thing around I've got to get to the right data and be able to contextualize it and have the knowledge around what that means and being able to program analytics and whatnot. And that's where BOBST, you guys are the experts in your industry, and that's where your real value is. And so, like you said, it's why go reinvent the base? You strategically said, I'm going to go build a whole service and all kinds of new things on top of infrastructure that you can get. So, I think that's a key realization. We've seen a lot of reinvention in the industry. Like all new industries start with folks kind of trying to build a little bit of everything because it's still sort of emerging. And then what happens over time is that the infrastructure becomes more and more consistent. And then it's about building necessarily unique software and hardware on top of it, around it, and ultimately about that domain knowledge that really matters. And that's where of course you guys, BOBST, excel in your space. And so, I think it's just been a really good engagement all the way around, and just the importance of kind of bringing together all these different elements to make stuff happen. So a couple other questions I had, and then we don't want to get to the Q&A ones that are coming in. So Luciano, so as you guys evolve BOBST Connect, are there some other technologies, anything's fair game here, is that you guys are looking at, stuff that you find interesting, out there in as I would call it, advanced class?
So I also, to answer to that, I want to piggyback something Steve said. So of course, machine learning is a key part of what we're doing, and from the very beginning, when we try to incorporate machine learning, we saw that the main challenge is to wait until you get enough data, especially given the complexity of our machines. Developing predictive algorithms is really hard. In the sense, the machine is super complex, and every client has a different set of different variables and different environments, and so build the reliable machine learning models out of this data, out of this complex environment, requires a lot of data. And this is something we start to have now after a few years of piloting and then putting things in place. And you're looking into all the things offered by Microsoft to have the basically a pipeline of machine learning where we can very quickly put test models, evolve models with the data that has been streaming, and that's a key point that we'll be working really hard next.
Cool. Yeah, that's the evolution. It's as Steve said. I mean, as you're both saying, it's kind of get things connected, figure out how to go scale it, get that initial visibility, and then start getting into the analytics on top and driving new outcomes. And I mean, you guys, I could see all kinds of new services and different things you bring out over time. So yeah, sky's the limit as things grow. Sarah, maybe we should go to a couple of the questions and we'll kind of continue conversation as we go.
Sure. So the first question that came in is a question for Steve. And the question is, can digital twins be run as an edge module to allow edge app development using the similar graph-like queries?
Yeah, that's actually a great question. It's interesting you should ask that, because my day job for the most part now is all around Azure Digital Twins. The short answer today is not yet, or no. It's no for today, I guess is the right way to say that. It is a high priority for us to do, though, because we know it's a use case that we think would be very useful for folks, for sure. But it's not supported yet, but it is definitely something that we plan to do.
Okay, thank you. And then the next one, Jason, I think is probably going to be a question for you. Is there a number of units where using something like EVOS and then Azure IoT Hub and Azure IoT Edge runtime solutions make a business sense?
Well, I mean, I'll let Steve speak to Hub and all that, but from a baseline orchestration standpoint, I'll say, if someone's just getting started with a use case, doing that first POC, oftentimes they don't understand the value of what ZEDEDA does, because you just haven't hit that scale factor yet. Party of few, yeah, no problem. Very, very consistently, once, I mean, and Luciano, you know this firsthand as you guys look to scale your solution, is once you get past, around 50 deployments, it is just not possible to do manual, updates of everything to get visibility across a landscape, especially when you have a very complex landscape. So it's around 50 to 100 edge deployments that we see that it just becomes not possible to do that securely and make business sense, in terms of doing it manually. So that's the consistent thing. So we've literally had conversations with customers that we talk about, and like they just haven't experienced that pain yet. So they're just like, oh, okay, cool, but I don't know, it's something I probably could do. And then literally like a month later, they come back, it's like, okay, yeah, I need what you do. This is really hard. And so I think that's a key part of the value is when people are ready to scale. I don't know, Steve, if you had anything to add, or Luciano, on that, just in terms of what you've experienced. Because I mean, Luciano, you guys obviously were looking for a solution for a reason, as you look to grow, BOBST Connect. Any other comments on that?
I think 50 is quite a high number. When we only were about 10, it was already getting really hard to manage those devices.
Yeah, it's tricky.
I think the message has to be clear. IoT Edge is a very, very good tool for you to manage the software that you build. Your use case is for that, IoT Edge is sufficient. But to manage your devices, you need something else. So there's a lot of complexity in managing your physical devices and the OS that runs in there, and at least as of today, the Azure IoT Edge doesn't go that far. So maybe when you have enough devices that perform an Ubuntu update takes more than 1 hour, then it's already ZEDEDA is already important to have a tool like ZEDEDA.
I would add to that to say, I mean, the numbers all sound reasonable. I mean, once you get into a double-digit number of edge boxes, it can be onerous to roll them out. But for me, it's also as much a function, or more of a function, of how much IT capacity you have and IT skills in the field, and where these devices are going to go. So I've worked with manufacturers that have manufacturing plants all over the world, and they have no IT staff in many of these manufacturing plants. So they've got to have a skilled worker go out and hand install some of these IoT devices, because they don't have sufficient connectivity to do it remotely, or so some of it comes down to where they're going to go and what kind of IT capacity and skills that you have out in the field where the devices will be, or connectivity to them as well. So that's another factor. I mean, if you've got good connectivity and good skills, and 10 manufacturing sites, then, that may not be a big deal to do, 10 or 12 or 20 or even 30 IoT edge devices. But, if you've got to do, like one of my customers, 40 manufacturing plants spread out all over the world, they're not going to do that manually.
Yeah, no, it's the inherent complexity plus the available skill sets, as you said, Steve, I think is key. And, kind of to summarize, the webinar title, the easy button here. I mean, what we're talking about, get a box with EVOS installed. You can install it yourself, or increasingly we're seeing it pre-installed. I don't need to know anything about IT to plug a box in, get it on a network. It then creates a crypto-based ID off of the root of trust. So, like PM as an example. Now you can no longer log into the box locally. It gets secure dial tone to the orchestration cloud of choice, and of course, that's what we're offering here. And then you just start, finish onboarding the box, and you start clicking down applications, and you can do that at bulk. And so this is the process. Just a few simple steps and go, and then you can start managing everything remotely. And so that's a really good point, that the simplicity of it in addition to the scalability. Sarah, there's some other questions.
There are. The next one, Jason, is for you, specifically to talking about ZEDEDA's solution. Is there an on-premise option available for very large sites, or is it only available cloud hosted?
So today we're only available cloud hosted. We are looking at, we're architected to where we could technically run anywhere. Of course, when you start doing on-prem, it greatly increases the complexity of offering continuous updates to your solution. Many times when we get asked the question, once it's clear that while we're a cloud-based orchestration solution, Eve, the data can stay on-prem. Data goes wherever you want because we're not in the data path. Often that concern is removed, because of course the data being the most critical asset to protect. We protect the infrastructure, of course, but so we're evaluating it. We feel like most things are headed towards edge computing without the cloud involved in some case is just legacy apps. The cloud is part of edge computing, we believe. But we're evaluating it and looking at it, and for the right use cases, certainly all doable, but not today.
Okay, thank you. And then the next one is for you, Luciano. Could you talk about what the biggest benefit of the connected solution is to BOBST end users? So to your customers, what's the biggest benefit?
It's hard to pinpoint one biggest benefit. I mean, there are quite a few. I guess some of them are things that for the customer they require us to have in this day and age. They like an example we've always used. The client will invest a large amount of money in a tool to manage the printing process, and then by the end they set out all the parameters. He doesn't want to put these parameters on a USB key and take to the machine so they can start printing, right? So this whole workflow needs to be automated. It's not something that we can afford not to have nowadays. But moving forward, I think there's a number of things that will give high benefit for the customer, in the sense with all the data we can collect, we can give them information that today is very hard for them to get. For instance, we can say that they can improve productivity of one machine by just improving how they load the cartons. We can show that 40% of the time the machine is stopped is because there's not enough cartons on the feed, and then that alone is maybe a small change for the customer to do, and that can improve the productivity I don't know, 3 or 4 times. So I guess I don't see one single benefit, but this just by having this connectivity, by collecting this data, there's a number of things that you can just add on top and bring that to the customer.
Okay, that's great. That's great. And the next one I think is going to be probably for a combination of Steve and possibly Jason as well. Any plan to support IoT Edge in lightweight Linux distros? So something with a minimum runtime, like Docker or Moby and company, without the traditional services typically included in servers, to optimize bandwidth and for other reasons.
Yeah, I would say we do want to do that. We want to push IoT Edge kind of further down in terms of the capabilities of the box needed to run IoT Edge. It's not on the near term roadmap, but we do look at it constantly as to how much more lightweight can we get. So, for example, we're looking to the main components of the runtime. We're looking to optimize those a little bit to make their resources requirements a little bit tighter, and be able to scale those down. So we are working kind of each quarter, each semester to make the IoT Edge runtime more and more lightweight, so that we can with the target to support lighter weight Linux distros. And part of that's because we in IoT Edge, which is itself open source, we use open source components, many of which also have dependencies that we have to that we have no choice but to carry along with us as well. And Sarah, if you want to, I can actually go ahead and answer Alessandro's other question here as well.
Yeah,
about IoT Edge is a Docker container-based solution, and ZEDEDA supports containers as applications. It's a pity to have a full OS between the Edge runtime and ZEDEDA. So the components of the Edge runtime themselves can run in Docker containers. So it might be possible to run those natively in those containers, but today we could even do that potentially on the Kubernetes support that they have. So IoT Edge can run in Kubernetes with the IoT Edge runtime components running as Docker containers. Now, we haven't tried to run it on something that just supports containers outside of the context of Kubernetes, but we haven't tried that, and it's not necessarily a supported solution today, but the runtime itself can run in containers.
And I think key to that, number one, so there's a variety of different ways that you can deploy Azure IoT Edge. EVOS as that base layer, well, first off, it's 512 megs of memory footprint, so much lighter than a traditional server operating system. I mean, some of the data center solutions, the footprint's more like 64 gigs of memory versus 512 megs. And then we have the 2 cores, so it's the 2 core requirement because there's an extra copy of Eve running at all times. So on one hand, there's various ways to deploy IoT Edge, but the reason to deploy on EVOS is all of the extra benefits that you get on top of, just hosting VMs or containers. The security benefits down to silicon, root of trust, distributed firewall capabilities. So I can say this app can only talk to that. That's important when you're deploying, whether it's, if you're an OEM that's deploying machines in a customer environment and you don't necessarily own that network, you need a way to guarantee that traffic is being routed appropriately across that network. So there's those capabilities. There's that notion of the open ecosystem that's being built around it, in that Android model. So on one hand, you could go deploy Azure IoT Edge on some, whatever version of Linux you'd like, but the benefit here is all of those extra value points that come around it, the ecosystem around it, and it's actually a very lightweight, base in its own right. So that's the reason we're finding a lot of folks are attracted to that combination.
Great. Thank you for that. And then the next one, Steve, who provides professional support for Azure IoT Edge? Is that something that people can buy a support contract for?
Yeah, I mean, the enterprise customers are generally going to have a support contract from Microsoft that will help expedite any support issues with IoT Edge. For IoT Edge, you can open support tickets through the Azure portal, just like any other project. It's also, IoT Edge is open source, so our developers are pretty active in the issues part of GitHub as well for support. Okay. But yeah, you can open tickets through existing enterprise support agreements with Microsoft as well.
Okay, great. And then I've got one last one here. And Jason, this is going to be one for you. You talked about trust fabrics at the very beginning of the presentation. Can you recommend any resources that would be good for people to learn more about that?
Yeah, so actually, well, first off, part of the reason I joined ZEDEDA is I think that what we're doing is key, as a key element going towards this vision. So this concept of trust fabrics, a good kind of starting resource is go to alvarium.org. Alvarium is a Latin term for beehive. Like we chose that because it's like interlocking honeycomb patterns. But so I had led before coming to ZEDEDA when I was CTO at IoT and Edge at Dell Technologies. I had led an effort with a team developing this concept around trust fabrics, and this notion of taking layers of trust insertion technologies and then binding them together with a framework done in open transparent collaboration. And by trust insertion technologies, I mean like silicon-based root of trust, open APIs, confidential computing, yes to distributed ledger, immutable storage, all these different things. And if you bind these things together with a framework that also includes algorithms that score the confidence of data based on how it flows through an instance of a trust fabric, this is how you get to this scaling of interconnected ecosystems. This notion of I can apply metadata to data and with that a confidence score, and I can send it out into an ecosystem and exchange value based on policies that I set, and that confidence for the person that's receiving it. So there's a video there that kind of gets into it. There's a lot of conversation spinning up. Dell, Intel, IOTA Foundation's involved. We're getting other people involved, and it's part of the vision. This is further out, but I think that the net message, kind of when we were setting it up, is the only way to get to that longer term vision, this interconnected ecosystems, a true Internet of Things, is you must have at the root an open foundation. Imagine if the Internet was owned by one company, it just wouldn't work. And so trust fabrics, check out alvarium.org. There's other stuff online, just around data confidence and whatnot. But that whole trust conversation is going to be spinning up, I think, quite a bit over the next few years. And it's all about, solve business problems today, develop new services, do all kinds of cool stuff like what you guys are doing at BOBST. And we're seeing a lot of stuff, out there. But think about how you architect today to be able to get to that type of future in the long run. And it requires an open path.
Great. Thank you. And I put the alvarium.org URL in the chat for any attendees that might want to go take a look at that for more information. And with that, we've reached the end of it. So just a couple of more housekeeping items. For our winner of the Microsoft Surface Go 2, the winner for that is Young Tran. So I will contact you via email later today and we'll get your address and get that off to you. So congratulations.
Well, congrats. I feel like I should have gone and play a little drum roll or something.
No, I know we should have had something there to make it a little more exciting next time. Luciano, I know it's late for you. Thank you so much for joining us and telling your story with BOBST. Steve, thank you so much for sharing your expertise for Microsoft. Jason, thank you as always. To the attendees, thank you for your time and for all your questions. We'll follow up later this week with a copy of the presentation as well as a copy of the slides. And certainly reach out if you have any questions or need additional information. So thank you to all of you and have a great rest of your day.